about inverses, picking up where we left off on yesterday. So you guys said yesterday that it seemed to not be so bad, so I'm hoping that today you will still say the same thing. Let's just refresh our memories quickly on what happened yesterday. We were talking about inverses. We talked about, for example, in this problem, we talked about how if you have some numbers and you map them on to some numbers in the range, the left side being the domain, the right side being the range, you have to subtract 2 to get from the left to the right. Well, if we work backwards, in other words, if we do the inverse of what we were doing, you have to, of course, add 2. But when you do that, these numbers over here, which used to be our range, are now our domain. And the numbers that used to be our domain is now our range. So, all right, so the inverse function we said is going to be x plus 2. Because to work backwards, you do the opposite of subtracting 2. You'd have to add 2. Oh, gosh. All right, we talked about how when you do the original function and you comp it with the inverse function, you're always going to end up with the identity function. And this is remember that the identity function is x. Regardless of which way you do it, you end up with x. And then we talked about finding the inverse and verifying that you get the identity function. So I don't think I talked in great detail about this, but if you have a function, f of x is equal to x over 10, well, if you're dividing x by 10, then to do the inverse of it, you have to multiply by 10. So you're going to go 10 times x instead. So when you comp the 2, the original function with the inverse function, you're going to end up, of course, with the identity function, like I just said. All right, functions are said to be 1-to-1 if what happens, you guys? They're 1-to-1 if what?
If they have an inverse. Yeah.
If they have an inverse. If they don't have an inverse, it's not 1-to-1. It's not 1-to-1. All right, so we talked about the horizontal line test very, very briefly yesterday.
Mm-hmm.
If it passes the horizontal line test, then what does that mean?
It's
Then it's
inverse.
1-to-1. Yes, it's 1-to-1 if it passes the horizontal line test. All right, so in this case right here, we had a parabola. It was a function because it passed the, well, it was a function because it passed the vertical line test. But it does not have an inverse because it does not pass the horizontal line test. It touches in 2 places. This example right here was not only a function because it passes the vertical line test, but if I draw horizontal lines, it also only ever touches the graph in 1 place. Therefore, it also has an inverse. So we call this one on the right 1-to-1. We call this one just a function, but it is not 1-to-1. Has an inverse, does not have an inverse. But let's start talking about the algebra part of that, because that's really what you guys need to be comfortable with. Yesterday, I do not think I had you guys write this down, so today I want you to write them down. To find an inverse algebraically, the first thing that you need to do is decide if it has an inverse. So that means it has to pass the, if it has an inverse, it has to pass the what, you guys? The horizontal line test. HLT. Horizontal line test has to pass the HLT. If it passes HLT, it has an inverse, and you continue. If it doesn't pass the horizontal line test, you stop. You don't need to find the inverse. You would say it does not have an inverse, does not pass the horizontal line test, and you get on with your life. The second thing that you need to do, if it passes the horizontal line test, you have to replace f of x with y. And I'll explain, we'll go over 3 or 4 examples in just a moment. So after you replace f of x with y, the third thing that you need to do is switch the x and the y. You literally put the x where the y is, you put the y where the x was. Then you solve for y. Lots of algebra, lots and lots of algebra with this part. And then in step 5, you replace your new y that you just got all alone. You replace it with, remember this notation right here, we talked about it yesterday. What does that little -1 mean?
Inverse.
Inverse. It's the notation that you use to represent that you have found the inverse. All right. Do you have those 5 steps written down? Most of the steps, the only step that really involves some work is step 4 when you actually have to solve for y. The rest of them are not a big deal. All right, so have those handy, and I would like you guys to work through this example right here. F of x is equal to 4 divided by x minus 6. F of x is equal to 4 divided by x minus 6. So the first thing that you need to do is check step 1. Does it pass the horizontal line test? So my suggestion would be to go to y equals, type it into your calculator, make a graph of it. You don't even necessarily need to draw the graph on your paper, but you need to be able to look at it on your screen. 4 divided by x minus 6. You're going to get a graph that looks like this. I already have it drawn for you. You have to decide, does it pass the horizontal line test? Does it pass the horizontal line test?
Yeah.
Yes, it passes it because as you draw horizontal lines, it's only ever going to touch the graph in exactly 1 point, therefore it passes the horizontal line test. Okay, step 2. Step 2 says that you replace this f of x in your function with a y. So notice I just completely rewrote this, but instead of writing f of x, I wrote y. Easy step. The next thing that you need to do is switch the x and the y. So this was your y, I put an x there instead. This was an x, I put a y there instead.
Wow.
So far, so good?
Yeah.
Should not be a big deal so far. I'm going to erase here. All right, the fourth thing that you need to do is take what you did in the 3rd step and solve for y. So notice for step 3, I have x equals 4 over y minus 6. I have exactly the same thing written down as the first step in number 4. And all I'm going to do here is solve for y. I have to isolate this variable. I need to get y alone. So to do that, I have to get rid of the minus 6. So to do that, I have to add 6. But if I add 6 to the right, I have to add it to the left, leaving me with x plus 6 is equal to 4 divided by y. Now, I know I have told you this before. If you've had me before, I know I've told you this before. If the variable that you are trying to solve for is on the bottom of a fraction, as it is right now, and it's all alone, all you have to do is switch it with the other side of the equal sign. So this y goes over here where the x plus 6 is, and the x plus 6 goes where the y is. So I've replaced x plus 6 with y. I've replaced the y with x plus 6. Therefore, my new rule is y equals 4 divided by x plus 6. And then the very 5th step is to replace your y with f of -1 of x. So it's 4 over x plus 6. How do you feel about that? Okay?
Cool.
All right, let's try another example.
It's coordinated.
Yeah,
So the 5th step, that's what the inverse is?
that's the inverse, yep. Number 2. F of x equals 2x minus 7. It's a line. Graph a line. Does that line pass the horizontal line test? It does pass the horizontal line test, so you keep going. So step number 1, pass this HLT. Draw lines, always crosses in one place. Passes the horizontal line test. I go on to number 2. Number 2 says that you replace f of x, you replace it with a y. So you put a y there, everything else stays the same. The next thing that you do, the 3rd step that you do, is switch the x and the y. So where that y was, I put an x. Where the x was, I put a y. And now I solve for y. You are trying to solve for that y right there. What do? Well, first of all, I rewrote it. Step 4, I rewrote what I had in step 3. I added 7 to each side. Add 7, add 7. So I have x plus 7 equals 2y. To get y alone, I have to divide by 2, cancels my 2 out, my 2's out, so I have x plus 7 divided by 2. So my y is x plus 7 divided by 2. So I'm done. I just need to write it in inverse notation now, which means I need to take this y and replace it with this notation, f of negative 1 of x. Yeah?
Yep.
Okay. All right, number 3. I think this is the last example. Is it, you guys? Okay. Number 3, f of x equals, and this one, make sure, this is a good one, so, I mean, and a little trickier than the ones that you guys are used to doing. First of all, the original function is x minus 2 cubed plus 5, so if we could take a second to talk about that. What common function does this come from? Remember the common functions we talked about? I think they're from section 1.4. There were 6 common functions. One of them was x squared, one of them was the absolute value of x, one was the square root of x. Do you remember this, you guys? Okay, what common function does this come from? F of x equals, can you guys look back maybe at page section 1.4? Good morning! What? It's cubic, yes. How do you know it's cubic? Did you say that? I'm sorry. Okay, well, I didn't hear you. Remember, I'm the old lady at the front of the room. You see this, you guys? Oh, gosh.
But she's lost a
Do you see this? Third power, cubic. This is a cubic function, and it resembles the common function f of x equals x cubed. This is just a little review from what we talked about the other day. That's the common function, f of x equals x to the power of 3. So, you see the x minus 2 in parentheses? Important information, you're going to need to know this for Friday. X minus 2, what will that do to the graph? Move it. When it's inside the parentheses, it will move it
To
left or right.
Right.
It will one or the other.
Right.
But because it is minus 2, you would think it would move it to the left, negative direction, but it doesn't. It moves it the opposite direction. It moves it to the right 2 units. You're going to need to know that. But when you have this plus 5 at the end, that does exactly what you think it will do. It will move it up 5 units. So notice this graph that I had already drawn in your notes. It is shifted to the right, approximately the right 2 units, and then it is shifted up 5 units. Okay? Okay. So does it pass the horizontal line test?
Yeah.
Yes, it passes the horizontal line test. Passes the horizontal line test, so I go on to step 2. Step 2, I replace f of x with y. Y equals x minus 2 cubed plus 5, nothing else changes. Now what I need to do is switch the x and the y. Put the x where the y was, put the y where the x was. So I have an x and a y now. Solve for y. So I rewrite what I have in 3, I rewrite it in 4, and I solve for y. And this is the part that gets a little sticky. Depends on how good you are at algebra. How do you get rid of plus 5? Subtract 5. Subtract 5 from the right, you subtract 5 from the left. So what you have now is x minus 5 equals y minus 2 to the power of 3. So now, to get rid of this cubed, that's the issue. How do you get rid of something that is cubed? You cube root it. If you have something that is squared, you square root it. If it's cubed, you cube root it. So I take the cubed root of something to the 3rd power. But if I cube root the right, I have to cube root the left. So I take the cubed root of the quantity x minus 5. So now when I cube rooted the y minus 2 to the 3rd power, they cancel each other out. And it leaves me with just y minus 2. So then to solve for y, I have to add 2 to each side. You with me so far? So what I have left is the cubed root of x minus 5. Notice my root, my radical symbol here, ends after the x minus 5. The plus 2 goes after the radical symbol. So we add that onto the end. That equals y. The fifth step is to replace that y, this y right here, with inverse notation. F of negative 1 of x is equal to the cubed root of x minus 5 plus 2. How do you feel?
I'll take over the world.
You could take over the world. Great. Man, I did a good job then.